What's going on, guys? Welcome back to this video. Today we're doing HackTheBox and back to the binary exploitation track. Today's challenge will be on Leet test. So basically make sure to deploy the machine. So if you go now and examine the file, so ls, this is the file Leet underscore test, and now we execute check sec because we want to find out the nature of the protections on this binary. And luckily for us, there is no canary and position independent executable is disabled, which means we can leak addresses from the memory, and we know that these addresses will not be randomized every time the application is executed. But we have NX enabled, which means the stack is not executable. We cannot execute code in the stack. So since no PIA, so since pi is disabled, it means we don't have to create rope chains. Okay, so only NX is enabled. Alright, so the next thing we want to take a look at the binary using Ghidra, and specifically we take a look at the main function. So a couple of things to take to note here is this line. So we have this line where we generate a random value using the dev urandom. Okay, and then at the end we store all of this random value on local underscore 13c, where we use the old value of local underscore 13c. Okay, and we perform an AND operation with 4 Fs. Okay, you don't have to get into details of how this is calculated, but it's important to find out how this variable, which holds or stores a random value, is now AND with this value. And then we get into a while loop. The while loop asks the user to enter your name, and we use fgets, okay, to store or to read the user input and store it in local underscore 128, which is allocated to 80 bytes. If you take a look at the input allowed by the user, as you can see, it is 256. 256 is less than 280, which means all is good. The buffer is allocated to 80 bytes, which can contain the bytes entered by the user. So there is no buffer overflow in the variable local underscore 128. But the problem comes after. So then the application wants to print what the user has supplied via the input. So we printf hello, and this is the problem. Printf local underscore 28. So this is format string vulnerability, because we are using a pointer, okay, in the printf statement, and the local underscore 128 is controlled by the user. So when we read or when we use an argument in printf statement where that argument is controlled by the user, we open chances for format string vulnerability. Now, I know you may have never heard of format string vulnerability. That's why we're gonna just give a brief introduction on format string vulnerability. So we're gonna open this link, and here we read the description of this vulnerability from OWASP. The format string exploit occurs when the submitted data of an input string is evaluated as a command by the application. So in our case, it will be evaluated as a command because we can manipulate the input here the way we want, and then whatever we put in the input, it will be read directly by printf. So how do we, the problem is, or not a problem, the gist of this vulnerability is how to make printf interpret this as a command. So we already know that printf takes whatever the user types, but we want printf to interpret this as a command as explained here. So in this way, the attacker could execute code, read the stack, or cause a segmentation fault in the running application. If you go back to the code, we're interested in this line. So in this line, there is a comparison. So there is first the random value stored in this variable is multiplied with this, and then if it is equal to winner, we're going to break out of this while loop and read out the flag. Now, since local underscore 13c is calculated randomly here using div random, and since there is no way to interact with this variable, then there is no way to find out what is winner. If you go to winner, so as you can see, winner equal to cafe babe h. Okay. Now there is no way to control the random variable here, and therefore if we don't control the random variable here, we will not be able to make this statement equal to true. Thus we will not be able to break out of this while loop and get into the lines of code where it sends the flag with the output. So we have to convert, or we have to turn the existence of format string vulnerability here into a way that we can take advantage of. So the way is, we want to find out this variable, the offset of the random. Okay, if we find the offset of this variable, we'll be able to somehow perform some calculations, and then using the format string vulnerability, we will be able to write whatever we want here on the winner. If we are able to control the value of the winner, okay, then we will be able to break out of this while loop and directly send the flag to the output. So format string vulnerability literally allows you to read variables, values, memory addresses, and even modify variables and memory addresses on the stack. So that's the danger of format string vulnerability. Now let's go back to the description. So how do we do that? Technically, we can use something called the format string parameter, like %x, %s. If we input these as the user input or part of the user input, then the printf statement will interpret them as a command and execute it. For example, scrolling down, as you can see here, x if we send %x as part of the input, we will read data from the stack. If we send %s, we will read character strings from the process memory. If we use %n, we write an integer to locations in the process memory. So we're going to take advantage of these three and use them in the user input. First, we're going to leak memory addresses using %x, okay, and then we're going to use %n and s to be able to control the offset and the location of the user input. Let's go back and see how this works. The first thing we want to do, we want to launch the application first and perform some testing. So if we enter %x, as you can see, we leak out a memory address. If we enter more than 1x, %x, so we have here zeros. Now if we use dot, for example, between them, and then let's copy that and use more than 1 %x. This is all of these. Look at this. So first we know that 1 %x equals or leaked this value. Now if we search for this value here, we cannot find it. But the thing is, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's enter more. Okay. take a look at this. These addresses, or these are leaked memory addresses from the stack, because we're using %x, and it is interpreted as a comment by printf. Now, if we use, if we replace, if we go back and use s, as you can see, the output was hello to HTTP, because this is executed as a string, and it will send the output, or it will read the strings from the stack hello to HTTP, which was found first in the code. If we use more than %s, so we have this, and we have null. So now, knowing that we are able to leak memory addresses from the stack using %x, we want now to find out how to go further and exploit this format string vulnerability. Now, luckily for us guys, Pawn Tools has this module where we can automatically exploit format string vulnerabilities. But we need a couple things first. So what do we need? We need the offset where we control the input. Remember that in format string vulnerability, we are able to leak memory addresses from the stack, leak values, and at the same time we can modify addresses. We want to find out at which offset we can start manipulating the stack or manipulating the contents. That's the first thing. We need the offset. Next, we need the memory address of the object that you want to modify. If we go back here to the code, we want to modify this. So we want to find out where it is, at which address it is. As you can see here, this is the winner function. This is the value of it. And we can find where it is, or what is the memory address of the winner. And lastly, we need the value. Okay, we need the value that will be used to modify the winner. Okay, now three things. Again, the offset, where we can control the input, the memory address of winner, or the value, or the variable we want to modify, and its and the value which we want to write. Okay, let's go back and use GDB to find this. Now gdb-q. Oh, first let's go back and find the offset first. So now we're gonna run this again and say this time px, or let's first type x. So we have this memory address. If we type px, now we have this. If we type more than px, or let's say mx, success x. Okay, let's try something as lx. Okay, good. Let's enter more than 1, like 10. Let's see here. So first we have the leaked memory address, and then we have 00100, and then we have these values repeated, as you can see. Let's calculate the offset. So as you can see, it exists 1 2 3 4 5 6 7 8 9 10. So it's a 10 offset where we can somehow control the input. If we send let's go back and say ABB, and then say %10 because it's a 10 offset, and then use $LX. Oh, okay, that's what we have to do. So these are the A's, right? And this is the output of this. Now if we switch that, if we enter first this expression, and then we say A, B, 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 now it's the opposite way. So it's a 10 offset, as you can see, where we can control the input. And how do we find that? How did we find that? Again, with experimentation. So we know that percentage X leaks memory addresses. We want to find out the pattern, okay, where the input that we send to the application is interpreted repeatedly. So we found it was at the 10 offset. And then as you can see, we were able to control where the input goes after or before the expression using the offset 10. So now we found the offset, okay, where we can control the user input. The next thing, we want to find the address of the winner function, and we want to calculate the value we want with which we want to modify the winner. So now it's time to launch DTP. And from here, let's disassemble the main function. So remember that that's the line here where we want to, the line which we want to bypass. So we're gonna look for this line in the code and make a breakpoint. Let's see. So scrolling up. Okay, here we have, as you can see, jump. And we have this line. Now in this line, there is a multiplication happening between a byte or a word, okay, with the contents of the EAX or RAX. So definitely we're gonna make a breakpoint somewhere here, because going back again, as you can see here, we read the user input, and then before we get into this, we want to make a breakpoint. So all this happens here, and this is the address of the winner, as you can see. So that's the address of the winner function. All right. So we found the offset where we can control the input. We find the address of the winner. Now we want to find out again the offset of the random. So the random variable here is calculated in the background, okay, randomly. We want to find out at which offset this value is calculated, because if we don't find the offset, we will not be able to perform this calculation here. So going back, let's make a breakpoint main plus 221. 221 is this, going back up here, defining the location here. It's where we perform the multiplication. Now next we want to run. Okay, now again, if we enter Lex, as you can see, we have a leaked address, and then we have a breakpoint. Now I want to examine the stack pointer or the instruction pointer, so we use x/i RIP. So the instruction pointer points to the next instruction, which is this, where the multiplication is performed. Now remember that this instruction multiplies the value, this value, with whatever value found at the RAX, so or EAX. Now going back here, this corresponds to the value of the local underscore 13C. So let's find out what offset it exists at. So P x/x and then EAX, or you can say RAX. It's the same. So AX or RX the same. So that's the offset. Now finding the offset, let's now examine the contents of the stack pointer. Let's output like 20 addresses, and then we say stack pointer. So as you can see, guys, the content of the stack pointer points out to the random value generated using this function. And we knew, because of this, thanks to this multiplication, that the variable containing the random value lies somewhat here. And as you can see, you can clearly find it here. Now if we grep lx, our input, so it is here. Now let's continue. Alright, so what's the next to do now? We want to find out if we can see that value or see that offset in the output. We want to leak that to the output. So we're going to use X, right? I know, but we have to find its index or its offset. So remember, the offset where we can control the input was 10. So definitely it is below 10, because the random value here, or the random variable, the random value that's stored in the random variable, is calculated way before we send the input. So if we try with something like percentage 6, okay, and then we say $lx. So percentage 6, we control the index, okay. Remember, this is a format string vulnerability, and every format specifier we send here is interpreted as a command. So here we can control the offset or the index, and here we can leak whatever found on that index. So let's see here. So it is this address. Let's go back. Hello 0. Okay. So that's the content of RAX. And we have a breakpoint. But as you can see, it is not what we expected. It is 0. So let's try with 7. So if we try percentage 7 and then $lx. Oh, we have to run again. Run. So percentage 7 $lx. Let's take a look, and looks like we got it. The contents of the RAX, as you can see at this offset, F5C4, and exactly when we entered the offset 7, we found this leaked. So this is exactly the offset of the random, the variable that holds the random value. So given that we found the offset of the variable that holds the random value, and given that we find the offset where we can control the input, and given that we also know the address of the winner function from earlier, we can now craft an exploit code where we use, as I told you guys, the format string from pawn tools to automatically perform the exploitation of the format string vulnerability. Let's take a look at the exploit code. So as you can see, we import it from the pawn tools. I will import sys because we want to find the address of the winner. I will import remote because we want to interact with the application remotely. Now let's take a look here. So as you can see, guys, first in the input we sent percentage 7 $lx, and I explained why. And then whatever sent by the application through the output, we grab it using receive line. And we use decode because decode, and we store that into random because we know what was sent by through the output by the application was the random that was calculated earlier here. Okay, I hope you guys are following up. And then after we are able to leak the value of the random, now it's time to, let's skip this line. I'm going to tell you how, I'm going to explain how this works. I'm going to skip to this line. So the payload, as you can see, uses the module from pawn tools, and here we have 10. It is the offset where we can control the input, and then we calculate, as you can see here, the winner address in the memory. We already know it, but we use the sim module from pawn tools, and here we have controller. Now what is controller? The controller here is the value that we want to write to the winner. We know the value of winner, so we want to write a corresponding value. Let's go back here to the code. I remind you guys that the random value that the application generates is actually ANDed with f, okay, and multiplied by this value to calculate winner. So we have to do something similar to be able to match the value of winner. So what we do here, we use the value of random, we multiply it by the value here, and then we AND it with f, which will result in a value that's actually equal to the winner, the value of winner, or stored in the winner. So if we go ahead and try this, clear Python 3 exploit, as you can see, we are able to bypass the while loop and send the flag to the output. So let's go ahead and try the flag. It is kind of 3. Channel already solved. Yeah, solved from before. So that was it, guys. And don't forget that if you want more information and more details about how to exploit buffer overflow and get yourself familiar with the basics, you can find the node file here I created. It's part of a channel membership. That was it, guys. I hope you enjoyed the video, and definitely I'm gonna see you later.